video, we're going to show how to solve this beam that we're showing on the right hand side of the screen. Essentially, we're going to get shear force and bending moment diagrams. First thing we want to do is ensure that the units that the program is going to use are consistent with the units of the problem statement, which essentially are metric units. So what we do is we click on this icon, and you notice currently RISA is in standard imperial, so we need to switch over to metric. Do that by clicking on the standard metric, right click that is, and then we press OK, right or left click OK. The next thing is to modify the grid. Currently we have a 30 by 30 foot spacing, and it would be ideal to have a grid that is easier to use in order to draw the model of the beam. So we go to this icon, modify the drawing grid, and what we're going to do is we're going to use 5 spaces at 2 feet each in the X direction. And so that will give us a total of 10 feet, and then we're going to do 1 spacing at 1 foot in the Y direction. So we have this grid now. That would be very useful when we draw our elements. We're going to do 2 elements. Anytime you see a discontinuity, whether it be a geometric discontinuity, a hinge, or a support discontinuity, you want to break up your beam into elements, multiple elements. So here we're going to have 2 elements, one from A to C and then C to B. In order to draw our elements, we're going to use this icon, draw member, new member. Most of the information here is not useful to us at this point. When we do design, this information will become useful. At this point, all we need to do is click apply. And so then we go to the first node, point A, click, left click, and that'll create a node N1. We move over to point C, which is at 6 meters away, and notice at the bottom, when we're sitting there, it shows 6 meters along the X, 0, 0. So if we click a second time, that'll create a second node, N2, and in the process it will create a member element between nodes N1 and N2. Next we click on the far end to the right, and that'll be at 10 meters from N1. We click again, notice it creates node 3, and in the process element N2 and 3. We right click twice and we get our cursor back. Next thing we want to do is we want to create supports. In order to do that, we're going to click the support tool, modify boundary conditions. Here we have a fixed support at B, so let's create fixed support first. The other thing we need to be concerned with is the problem moving out of the 2-dimensional plane. In order to ensure that it does not move out of the 2-dimensional plane, we need to fix the translations, out-of-plane translations, and out-of-plane rotations. So we'll fix those by pulling down this menus. I'll ensure that our problem stays in 2D. And then we click on node 3. Then we go to node 1. Node 1 is the roller, so we need to release the rotation and the X translation. Next thing we need to deal with is the hinge at point C. In order to deal with this, we double click on the first member. That brings up this window. We want to go to end releases, and what we want to do is we want to release end J, the second end we created. When we hit apply, it will show a circle, an open circle at that end. So we click OK. Then we go to the other member, member 2, and again in this case we are going to release end I, the first node we created. and so we'll have a second open circle. This indicates that there is no moment that is going to be transferred between those two members. Now we have to apply the load. So we go to distribute load. Notice we have three different ways of applying load. We can apply loads to joints, we can apply loads, distribute loads to members, and we can apply loads or moments to members. In this case, we're going to apply distribute load of 4 kilonewtons per meter to member AC. So we do that by typing -4, and the starting magnitude and the end magnitude is uniform. We then say apply, and we put the crosshairs over the beam and simply left click. That then creates our load. That's going to go in basic load case 1. We want all our, for this particular example, we want all our loads to go into basic case load, or basic load case 1. That will be useful when we get into load combinations. Next, we have a concentrated force on member CB. So we'll use this tool, and it's going to be right in the middle. Here we have lower and upper case letters. The uppercase letters indicate global coordinates that go with the global problem. The lowercase letters go with the member. So these are local coordinates, and they rotate with as members rotate. We also have moments. So we can apply concentrated moments anywhere along the length of a beam element. We have a concentrated force. We're going to go capital Y. That concentrated force is -18 kilonewtons. So we simply apply, and then also it's in the middle, so we're going to put 50%. We could also use 2 meters. And we again place the crosshairs over the beam, and we click, and there's our 18 kilonewton force. Now we are ready to solve the problem. But first, we have to create load combinations. And in this case, we have all our loads in basic load case 1. So we'll type in 1. And we're not going to factor those loads. So we'll just simply use a factor 1. Once we're done with this, we're then ready to solve our problem. We simply go ahead and click equal, and then solve. We get the results menu. We don't really want to use that. We can use either this. I prefer using this little M, and I'm going to click on it to bring up a window. It's going to help me show all of the results. So I'm going to go to joints. In joints, I have reactions, and force reactions and moment reactions. So I'm going to click on that, and notice I'm going to have my reactions displayed on my model in kilonewtons or kilonewton meters. The next thing I want to do is I'm going to do a shear force diagram. Pull that menu up again, and now I'm going to go to members, and in members we have member results, and here I can either get axial, shear along the Y, shear along the Z, and so on. I need the shear force diagram along the Y axis. Again, I'm going to include the magnitudes, and then I'm going to apply. There's my shear force diagram. I probably don't want to display the apply load, so I'm going to take and turn those off by going to the loads tab and then clicking don't show loads. When I apply that, notice I have a clean shear force diagram. If we want to do the moment diagram, we can then go back to the members tab on the set options recurrent view and go down to the moment along the ZZ axis. Apply, and there's my moment diagram. Hope this was helpful.